Hello, in this video I will show you how to use this collision group of properties. And first of all, main property here is collide with. There are two ways right now to define collide with property: everything and nothing. Later I will add other possibilities. For now there's just these two. So here to reference, first one set to nothing and second to everything. And as you can see, I have here this ground, static ground, this box. It's static, it's RayFire component set simulation type to static. So in the first example here I set it to nothing, which means I will just emit particles, but they will not collide with anything, not with fragments, not with column, with nothing. So let's take a look. And here you can see they just pass through the ground, and in the right example here you can see that they collided this ground, static ground, and then according to their lifetime they start disappearing. So this is one of the properties here in collision group. If you just want to spawn some particles, you don't care about the collision, you don't want to keep them in scene, just want to make your demolition more spectacular, but you don't want to waste your resources for collision detection, then just set here collide to nothing, and that's it. Next property is quality, and quality allows you to change how this collision detection works. So there are two ways right now, actually three, but low and medium works pretty the same way. So I have only two options here to reference here: medium and high. And the medium allows you to detect collision, but some of them, some particle probably will leak through the collided object, but still there will be some, you will see that some of particles will stay on the ground. And high quality means that it will be very careful with collision detection. So here you can see in this left example, they kind of collide to this ground. They don't just pass through the ground here, but not all of them. If I will take a look at this from this bottom, you'll see there are a lot of particles leak through this static ground. You can see how because there are a lot of particles and none of them have enough resources to detect this collision. And in the right example here you can see it's very careful with collision detection. All particles collide to this ground. Okay, next property here is radius, and it's pretty straightforward property. This property allows you to define a particle radius. Every particle uses the sphere sphere collider, and this radius property allows you to define its size. In this case I used value 0.1, and in this case I used value 1. So in this way you can tweak size of your particles. Here you can see every particle here. So again, you can select this object, go to its debris host, and then open this collision rollout here, and then you'll see this colliders, these green spheres. And in the right example here, I used value 1, so you can see sphere size here is much bigger. But again, maybe you want to have even lower sphere size, so your object will collide with this ground not by its edge, but maybe it's some center. So again, pretty straightforward property. Just play with it to see which value works for you. Well, obviously this not looks okay. And next property is dampen here. And first of all, let me select this rock. As you can see, there are two ways to use dampen. It's by properties, which means by this dampen minimum and dampen maximum, or you can use by physical material. In this case I'm using this properties. So first example shows you very low dampen, starting from 0 to 0.1, and this is basically works as a friction. For the second example, I used value from 0.8 to 0.9, which is a pretty high friction value. And for this example, the last one, I used uh, very low value minimum for minimum and high value for maximum. So some particles here will slide down, and some particle will have very high friction and will stay at their position. Let's take a look. Here you can see they slide down here. All the particles at the center, they just stay at their position. And on the right side, we have different, every particle have different friction. You can see that some of them slide down quickly and some of them slide slowly. So this is how dampen works. Also, you can set this, another example show you how it works. So again, this dampen property depends on what kind of material you demolish or simulate. It's up to you to decide, but in case you don't want to change these properties manually for every object, you can set here to by physical material, and in this case I select for this rock in rigid component, I set here in physics I set dense rock. For this one I set here glass, and for the last one I set here ice. So all of them will have different mass, different friction, different bounciness. And so let's take a look again. And in this case, when let me select this object. So when you will start play mode, you will see that it will set all these dampen properties accordingly to collider material. So let's start play mode. Okay, and now after that you will see that every rock has its mesh collider now, and every mesh collider has its own dense rock material, which was created accordingly to this RayFire rigid material which you defined here. So now every dampen property you can see here, it was set to this physical material which you will see in mesh collider. So for this one I set it it was set to glass, so it has lower dampen here. For this one it's set to very low dampen minimum and dampen maximum value. All of this because only because I have different physical material on my mesh collider. So if you don't want to think about all these properties, you just can set the physical material and it will set it all automatically. And again, now you can see that they all simulate differently. This is ice particles, this is the glass, and this is dense rock particles. So again, it's up to you. If you want to tweak them and make them simulate just like you want, then you can play with properties and set here to by properties. If you don't care, just set it by physical material, and this particle roughly will be simulated just like fragments. And next property is bounce property here. And again, they work in pretty the same way, just like dampen. They also can be set to by properties or by physical material, and I have only in this case I set it to by properties here. And again, for this one I'm using very low value from 0 to 0.1. For second I'm using high value 0.7 to 0.8, and this one will have average value 0.2 to 0.4. This is our default values. So let's take a look. So you can see at this left example, completely no bounce. They just fall down and stick to the ground. And that's it. And in the second example here, they see that they're very bouncy. They're jumping again and again. And on the right side, we have average bounce value, so it just looks okay. Okay, that was collision group of properties. Thank you for watching.